Okay, good morning, everyone. I think we start. You may notice that we are missing a few people. They are still alive, but they will probably drift in course of this morning. So maybe if they come all together, we give them a welcome applause. But before we start, just for you to know that those who are staying in Polarig, Marianne, you are not paying for your stay at the reception when you check out, unless you booked yourself. It is prepaid by the Nansen Center. It doesn't mean that it's a free stay for you guys. You will receive an invoice in email that is basically the return payment to the Nansen Center. So you will have that in course of next week. And we will make sure that you don't forget to pay. I don't think we have any arrangement for that elsewhere. Do we have some of the same arrangement lost at Unis? The guest house?
I don't think so. No, you have to pay. You have to pay in the reception at Unis guest house.
Okay. Okay.
But no. At least for some of them.
Yeah. If you for some reason can't, drop me an email.
And put it on the invoice.
Yeah.
Okay. So and also to the people online, welcome this morning. Apologies for starting later than originally scheduled. The reason for that was decided last night, and apparently for some it wasn't enough just to delay it by 30 minutes. It might have been delayed by the entire morning perhaps, but we don't have time for that. Okay, so I'm going to just give you the summary of the Synergy group, and you see a number of contributors here, and for sure you are all welcome. If you don't find your name on this, you are all welcome to contribute. So don't hesitate to contact me or some of the others on this list and say that you want to contribute. So what we discussed and concluded in this group is a number of recommendations, and some of them has been already mentioned, not just in the Synergy theme, but also by many of the other theme presentations. It is important that we take advantage of these existing natural laboratories, which includes the Agulhas Current, the Gulf Stream, the Med Sea, Lofoten Basin, Fram Strait, then the tropical instability waves, river plumes, the Californian Current as well, including the submesoscale areas around the Catalina Islands. Many of these places are kind of without existing in situ observation systems regularly operating. Others do, in fact, have that. And particularly the California coastal current, or California Current, is known for being quite well monitored with routine observations. And that includes, among other things, 5 glider sections from typically San Francisco down towards the border to Mexico. And these glider sections are operated autonomously, but it means that we have regular profiling of the upper layer ocean, temperature, salinity, and also with velocity estimates. So this is a powerful in situ observing system already, and it's quite valuable to connect to these sites because of the fact that there's already a significant investment in the in situ observing system. What we also want to do in the Synergy group is to start now to establish this classification system for mesoscale features. We've seen them in SAR images, and we've seen them across all the other remote sensing instruments. And it is perhaps time to sort them in a way that it can be easier for people who are new coming into this field to explore the data in more classified categories rather than randomly. And we saw a little bit of what Justin presented the other day on this as an illustration of how he did the classification of the SAR expressions into a set of different categories. And that can be followed up and extended into more mesoscale structures in general, seen not only in the SAR, but across the other sensors as well. And it could be that you group them into atmospheric expressions, oceanic expressions, and combinations of this, of course. Another issue is that these frontal boundaries that we see in the SAR images that sort of are sometimes bright, other times they are dark, and sometimes they are both bright and dark, do have, at least on some situations, a clear indication to us that I am a converging front, so I'm bright. I am a diverging front, so I'm dark. But it doesn't always be like that. It's dependent on the wind direction as well. And when the wind are blowing too strong, these fronts may also disappear because the surface roughness is entirely now dominated by surface stress imposed by the wind. The opportunity to go from surface expressions into the upper ocean, this 2D to 3D approach, is something that has been proposed for 10 years already. And we are not there yet, but I think we are gradually accumulating more and more understanding to start to do this more systematically. And what do we mean with that? What is that to go 3D? What is that essentially? It is primarily to be able to take the surface expression and consider the vertical extent of that expression into the upper ocean, down at least to the mixed layer depth. That will need a decent amount of in situ data to systematically be able to do this. And hence, we are back to the issue about the taking advantage of natural laboratories with extended in situ observing capacity. Then we have this Doppler, DOPRIM, which stands for Doppler and Radar Imaging Model, which is developed by Vladimir Kudrwatsev and his colleagues, and which has primarily been made for C-band. And I think with the view of future missions, we need to extend this to different frequencies. And it's a full possibility to do that within this DOPRIM model code. And it shall be done. And this is also where fully quadpole capabilities also resides inside this DOPRIM model. It can do all of that as well. It's also something that we would potentially discuss with Vladimir, and I know he is open for it, that toolbox should be made available to us all, meaning that everyone can start to learn to run this tool and then eventually to take advantage of it and contribute to the gradual, let's say, improvement of it. So then we have the aspects of the synergy which is connected to this sometimes unfortunate situation that the Ocean Color remote sensing group and the SAR remote sensing group are not cross-fertilizing their view on and knowledge. So we have to avoid this silo-like development. and go more Earth system. That again also calls to the possibility to establish a joint analysis and interpretation platform. I just said that the DOPRIM could be and should be included on such a toolbox or platform. And it is also perhaps with the onset of more capabilities with digital twins, maybe that is a way that shall trigger a lot more of this synergy kind of approach, where different groups with different skill and knowledge, in fact, become more interactive and collaborative through the development of these digital twins. We will propose this ocean test facility, and this is a remark that if you think that you can make a digital twin of the ocean that is able to replicate the real ocean, then the question is, how can you do that without high quality in situ data? So this is an issue that, well, can you do it at 300-kilometer resolution, taking benefit of Argo floats? Maybe, but that will be at a digital twin of the 300-kilometer resolution kind of mapping of the ocean. But the observation system at 300-kilometer resolution is in fact already carries into it signals that is residing and developed at much finer spatial and temporal scales. But we are not at all able to invoke that and partition that if you just have an array of 300 by 300 kilometer, which is typically the Argo profiling floats system today. So we need to go much finer in spatial scale for sure, and also in time. So there is a plea for high quality in situ data. And it's not just meaning that it is the Argo floats at the denser spatial resolution. You have to be in the atmospheric boundary layer, at the surface, and into the upper ocean. And this is an example of this sort of view, which you can see in a variety of type of demonstration or examples. This one has the red line indicating the space-time characteristics in the atmospheric boundary layer. The slope indicates that atmospheric boundary layer activities has a much more rapid transition from fine scales to larger scales. The ability for the atmosphere to make that sort of connection is clearly much faster than it is for the ocean. Hence, you see the ocean and its pathway having a much weaker slope. So then you have these two layers, the atmospheric boundary layer and the upper ocean layer. But they do have one common boundary, and that is the surface. And that is those green lines that goes and blue lines that goes back and forth between the atmosphere and the ocean at essentially all scales. And this is the one thing that we are going to go after and try to do something with that. You saw it yesterday in the example of the Miro that the Ocean Wave and Doppler gang presented. And what they had was a number of characteristic features, processes, that all fits into this. And you can imagine that the different sensing methods will be having its unique contribution to mapping out this more quantitatively. It's a major challenge. So the last bit of recommendation for us is the wish for having quad and cross polarization, basically for all SAR missions to fly. And it's a question whether we will have this. I mean, Sentinel-1 next generation doesn't necessarily offer this. We don't know. And we need to push hard to sort of be heard about this. And we need to argue for why we want to have this in a way that justifies eventually the extension to to full polarimetric capability. The same goes for the Doppler. It is not just perhaps to say that, well, if you get the single loop complex, we have the ability to take out the Doppler. We need to be demanding more and arguing for more than just that, because there is an issue with the pointing of the antenna that needs to be very precise and very well monitored. And that is something that is not going to be just found a solution half a year before launch. This is something that needs to be part of the whole mission requirements documents from a very early stage. We learned yesterday or the day before that the biomass mission is going to give us some possibilities in the coastal ocean and in the marginalized zone. And in fact, there is already agreement with the operation of biomass that when it's going to do orbit maneuvers, because it's going to fly in certain characteristic orbits, and in between, when they do the orbit maneuvers, it's no longer targeting sort of rainforest monitoring mission or ice sheet and glacier monitoring mission. It is open for additional possibilities. And this is where the coastal ocean mapping will be possible, and coastal to open ocean. And the super sites are already being identified. One of them is the Agulhas, another is the Malvinas. The third one is Kuroshio. And there is also an area in the tropical Pacific. So I think we will certainly be very keen to see how this P-band radar can give us new insight into the surface roughness associated with wind waves and currents and so on. It would also be very nice if we could, with the next generation Sentinel-2, see the opportunity to extend the sensors with a dual thermal channel. So this one is today flying with without the thermal bands, and it has a super nice resolution, and it is great to see. Unfortunately, without the sea surface temperature, we are still often in this, what are we seeing here? Is it something completely connected with biological or biogeochemical kind of activities, or there's something to do with mesoscale processes? So it's important to see the opportunity, or try to get the opportunity to have this SST channel on as well. Then we are being reminded about points that we illustrate a little bit our lack of capability. And one of them is, in fact, that the Sentinel-3 next generation are going to split the two sensors, the ULSI and the SLSTR. So we will not have joint at the same time measurement of surface temperature and ocean color. And Craig just arrived in the audience, and he may potentially think about this for a second and explain who made that decision. We were not asked about it. So this is just reminding ourselves that if we are not strong enough and persistent enough in our requirements, things can happen just in front of our eyes that can be completely disruptive compared to what we hope and expect it to be. So that's our three set of recommendations. And we have looked a little bit onto the raft structure of the white paper. Again, the authors are there, and we expect more authors to come on here. In fact, I will send an email out to all of you with the indications as to how we plan to build up this white paper, and where you therefore can be invited to contribute. We see 4 essential sections: a background section, a section that documents the strength of SeaSAR synergy, and here we will go through an example of a range of examples of SeaSAR synergy, from internal waves to eddies to frontal structures and so on and so forth. And they will capitalize, therefore, on the natural laboratories and some of the areas where we do have good access to in situ data. The schedule, we will also, of course, come through on the gaps and limitations here. And that is in addition to the lack of proper in situ data. Clearly, it's also pointing to other things, which is a bit scary, and that is that this remote sensing community that we are a part of is not necessarily growing at the same path as the amount of satellite data that we are being continuously serviced with. And are we able to keep up with the speed to sort of maintain a proper handling of this data? That's a bit of a concern here. And we will hear from Craig clearly about the future missions when he gives his presentation. There is clearly possibilities foreseen in future missions, but we also need to be very strong on highlighting outlooks whereby seemingly there's no yet solutions expected in the approved future missions. So this will also be part of it. So on the schedule on this, we will start this beginning of next week or thereabout by making this little email sent around to all the participants and the people also online with an indication as to what kind of input we would welcome from contributing authors. We consider this to be a little bit back and forth and some reminders and so on and so forth, but by the end of September, the first draft full white paper on SeaSAR synergy shall be ready. Then comes a round of iterations and updatings. And this will be led by the key authors and involve everyone who is on that author by then, so they can have a chance to look and update or come with new issues into the SeaSAR white paper. I think we all want to have these white papers assessed by some outside, let's say, reviewers or experts. And hence, the goal is to see an opportunity by mid-November to have the paper almost ready for a review, so to say. And this is, of course, not a review comparable to a review of a journal into or a paper into a international journal. But it shall have an opportunity to be a bit reflected upon by some outside knowledgeable people. And then having this done like this, I think we will be ready to have the refined white paper done by, let's say, 23 of December, 2023. So that's basically what we did, and we have already gone into the structure and started to sort of highlight elements that we need to take with us through the different sections. But you will receive this on email anyways. So I think that's the presentation in short from the SeaSAR Synergy Group. Okay. We do have time for some comments or questions or suggestions or whatever here. So please feel free.
Just a comment. I think that schedule really applies to all the themes.
Yeah.
And we should all drive to that, or it's not going to work. Right.
Just also a little comment that SeaSAR Synergy in that case is applied only to ocean applications. So maybe it's worth mentioning that SeaSAR Synergy for ocean applications, because for sea ice, of course, there can be many SeaSAR Synergy applications, but this is not covered.
No, thanks for that comment, Anton. I think that's very important, and it's something we need to think a bit about. Shall we do this SeaSAR Synergy also for the sea ice part, or will you in the sea ice group have it?
We will partly cover that with especially Ellis. Yeah.
We will partly cover that with the LNC band and a combination of passive microwave and SAR for ice type retrieval. But we will not touch upon waves in the marginalized zone with altimetry and all the beautiful things we can do there.
Yeah, so it is an issue here that we need to sort of chew a bit on and see how we will manage to have this properly handled. And it may be that we need to have some kind of a section on the marginalized zone inside this synergy.
It can be a section here, yes, as a part of the ocean.
Yeah. Very good. So in the chat, we have some comments. It's good morning to us all from the people on the online, from Christine, and then there is a remark from Bertrand. DOPRIM toolbox is already available. Importantly, it has been extended with Marcel, he is. Are you here? Still not here, but it has been extended with input from Marcel to include different spectra and configurations. And the DOPRIM has then to be compared with numerical simulations. And that is a point that, in fact, I didn't potentially have it on the recommendation, but I have it inside the chapter specified, and that is that we need to attract more interest by the numerical modeling community. And this is something that, it's not to say that this necessarily has to be operational models like CMAMs or so. This can be a range of models, experimental models and operational models combined. Or it's just that having the opportunity to see the numerical modeling community reflect on what kind of surface expressions we are able to produce from SeaSAR Synergy must and shall trigger their curiosity as to how is this being simulated in the model. And I think we have a job to do here in order to attract that numerical modeling community into this. I must say that we are extremely lucky at the Nansen Center. I can use that as an example, which basically is why I'm convinced that this is the way to do it. Because we do have this high-resolution sea ice model named NextSim. And in combination with that NextSim simulation model, which is in fact already now into an operational stage, we have this Sentinel-1 sea ice deformation retrieval, which is led by Anton. And these two type of completely independent ways of expressing the sea ice deformation are so nice to see in combination. You learn a lot from the interpretation of the SAR data by looking at the next simulations. And the next simulation learn a lot by seeing the real observation. And this combination is exactly what we will have to hope for. We can also start to do with the numerical model simulation groups, and particularly then being able to look at the surface expression to the mixed layer depth thermodynamics. We don't have to go to the complete 3D, but the upper layer to the mixed layer would be super nice to have the ability to always see the surface expression to the mixed layer depth from the simulations. So that's an important point. Christine, I see you are waving your hand. So speak out.
Good morning. Thank you very much, Johnny. My comment is that some of the themes that you highlighted in this are going to come back in the future mission session as well, that Craig will present later. And I just wondered how we wanted to manage the themes that are going to be common across, sorry, not themes, but the topics that are going to be common across the different themes. Because we're going to have different teams doing different papers without necessarily having full visibility of what different themes are saying. At the very least, we need to come up with a consistent message across the different papers. So I just wondered how we're going to manage that.
Well, it's a good comment, and to some extent, I hope we can manage that by having these internal reviews of the white papers. That some has to be instructed to some needs to have that task to make sure that that kind of consistency is maintained across the different white papers.
Yeah, it's important that we sing from the same hymn sheet so we don't contradict each other, because that would be very counterproductive.
Yeah. So maybe you will have, since you were proposing this or commenting on this important element, maybe you will be tasked with having that job.
Oh, great. Yeah, I've got nothing else on in September, October.
Very good. No, it's an important remark. So we will have to find the appropriate way of handling that.
Okay, thank you.
Okay, that's the SeaSAR synergy. I think we are ready to go on with the next group, which will be the technology and methodology. So Ralph and Justin.
Hello. All right, there we go. Yeah, so I drew the short straw. So we went at this at a simpler, more top-down point of view than what's been presented in some of these other breakouts. The philosophy here was that we're going to roughly give everybody who proposed a method to be discussed at this meeting, we're going to give everybody a chance to really describe and explain and come up with the reasons why the methodology is interesting and important, what recommendations that they would come up with, and give them a chance to advocate for this point of view in the white paper. So the methodology section was relatively large. We had 14 abstracts, and it broke down initially into 7 that were much more technologically oriented and 7 that were more geophysically oriented. And these are, very loose categorizations, but it was a way that we could organize the work. And the thing that really jumped out of this was that machine learning was playing a major role in all of these applications. And so before this meeting, each of the lead authors of these abstracts were asked to provide us with 5 slides that reviewed the current state of the art. These are the 4 questions that we were given at the initial part of the SeaSAR planning. So we had these 4 questions: to review the current state of the art, identify deficiencies, identify validation needs, and to propose novel approaches. And so we've had a little bit of adjustment through there. We received feedback from, I think, 10 total abstracts. Some of them had overlapping authors. And then some of the abstracts that were much more closely related to the Harmony mission felt that their interests would be best served by presenting their research and proposed solutions in the Harmony section. So that was a group of three abstracts. So really we're down to 11 abstracts. And nearly all the slides that we received were presented during the plenary. So this was the big thing that popped out was, I don't think that if you went back to any of these old SeaSAR proceedings, I would be very surprised if you would see even one application of machine learning from back in 2003. And yet for these methods that were proposed here, these methodologies, et cetera, they were dominated by machine learning. So that's a huge change in the last 20 years, an emphasis on more functional modeling initially. An example would be the detailed sea ice modeling with all the little boxes interchanging and exchanging information between one process and another, and then a machine learning approach. But the machine learning clearly requires the large data sets. And in 2003, it was very, very difficult to obtain even one SAR image. And now, thanks to the largesse of the European Space Agency, we now are drowning in SAR imagery. And I guess Johnny is saying that we don't have enough people to work on it, and maybe the machine is going to compensate for some of that, a small fraction, I would say, of that, but it is a way to make use of this data. And what we decided looking at all of this is that from this perspective, compared to 2003, to me, all of these applications were novel. So when we fit this all through, everything in this section was a novel approach. So we got very practical about how we organized the breakout session, and the focus was essentially on the production of the white paper. And we set up a schedule, and I think it's relatively close to Johnny's schedule, but we'll adjust the deadlines to match his in the email that we send out. But we focused on the deadlines, we focused on what would be covered and how it would be put together. So we tried to establish a shared document site, but that's turned out to be surprisingly difficult. Some people have to use Microsoft. Some people enjoy using Google. Some people cannot use Google. Some people cannot use Microsoft. It is surprisingly difficult to set up a shared site that doesn't conflict with the different institutions' requirements. And that is actually, in this day and age of collaborative writing and putting a document up on the web and all working on it, you would think it would be easier than it turns out to be. I mean, that's a crazy thing. So our schedule that we set up is that we set a deadline of 1 July for input from everybody, because half of the people involved take July off, and then the other half of the people take August off. And then the Americans, of course, never take any time off. And so, we were going to set, a deadline at some point, and they said, no, if you set that deadline, that means it's really this deadline. So let's just, fine. So we're going to get the basic input from everybody. They're going to address the 4 questions. From that, there will be specific recommendations associated with each research group. And our thought was to have them go start writing and really think to the future and get their recommendations out. Justin and I will organize this into a first draft by the 30th of September. And we're still kind of discussing what the format would be, but I think the option one is more likely, where it'll start with sort of an executive summary section that reflects the responses to the 4 questions and the specific recommendations. And that'll be a relatively short 1 or 2 page part of the paper. And then after that, we're going to take advantage of the electronic publication and have example 1, example 2, example 3, in which each investigative group gets a chance to present what they're doing, why it's important, why it's of interest to ESA, why it's of interest to science. They can really advocate for what they're going to do in the white paper in the context of supporting the recommendations in the executive summary. So we established an internal review by the 30th of November, and then a final draft at the 31st, because we thought that the external review was going to start on the 30th of, at the beginning of the year. So we're going to have to bump those up by a month in order to have a month for internal review in November. But remember, the US does take a lot of vacation time in November. So that's when we do things. So that was pretty much it. And so there were some other discussions here, and this was a little bit more philosophical discussions that maybe are of less interest to everybody else. But we wanted to look at the commonalities and differences between different applications of machine learning. And so there's one mode of thinking that, can the machine learning find something that the human scientists miss? Is it going to find some connection that we don't find, that we can't see in our imagination and our interpretation of the image? And so an example would be the boat wave detection compared with the existing state-of-the-art models. And he had the table, Bjorn had that table where we agreed with the literature, but he had some where he disagreed with the literature. And so that's the question, is what's going on here? And then in the sea ice modeling from Lauren, that can go through and a lot of this modeling is just sort of a linear modeling of a process. How much, you have the wind blowing across the ice, you have some sort of a transfer-like coefficient. And if you're blowing this much, the ice is moving that much. And trying to extract that out of the machine learning and determine whether or not some of the inherent hidden nonlinearity in the machine learning model is teaching you something about that. And can you outperform standard modeling? And then what Justin and I are working on, and Doug, is, can we teach a machine to recognize everything that we see by eye? We look at the images, and everybody here, I'm sure, participated in the contest and challenged themselves to recognize atmospheric and oceanic features in the SAR images. And if you haven't done that, you have to do that. It is important to challenge yourself to look at a SAR image. What am I seeing? You can't go forward unless you can say, this SAR image is telling me this set of processes is occurring at the time of sampling. And we wanted to know, could it recreate our by-eye classification? And we're learning that that is a surprisingly difficult job. And then, can't remember what yes, and then Martin had his research in which he was showing that he could, in a very practical sense, use SAR to study landform changes in regions where you could not go and sample in person for a variety of reasons: difficult terrain, regulations, seal migration. There were a whole lot of reasons why you couldn't just go in and measure what you want. You weren't allowed to fly a drone, for example, but you have the satellite, and you use the machine learning to track the variability in the near shore environment. So that's a very different application of machine learning. So machine learning means a lot of things in a lot of different contexts. And so, this is, I collected just a few things off the slides. Novel approaches, open science can improve efficiency, collaboration, etc. The Sentinel-1 product group is continuously improving the product as they should, and it's great. And then these 3 harmony talks, I believe, are going to be shifted to the other session. And then, the novel approach in geophysics, we had a machine learning detection of shoreline and track morphology. We had this SeaSAR project in which they're trying to create a database suitable for future machine learning based on every available IWSAR image in the Mediterranean and Baltic Seas, and cataloging this database of features. So they went through the IW and they did the same exercise that we did. And there was some overlap in authors between our work and their work, and identified, convected boundary layer, rain, cold pool, et cetera. And that data is sitting out there for future researchers to use to maybe train machine models. We want to, Lauren wants to study the changes in the drivers of variability in the sea ice. What's, these processes may change, and then how the key parameters that contribute to the variability in the ice question, those controlling parameters may change with time. And can we detect this secular change? Can the machine learning detect as many contributing, the different parts of the ship wake? What can machine learning identify out of that? And then, the other 2 things here, the same boundary layer state detection. And then, mine kind of stands out a little bit as an oddball here. It's back to the old-fashioned, old-school method of just building up from the SAR images, providing boundary conditions to a problem, and then using a lot of modeling to try to extract that information and extend it vertically into the planetary boundary layer. We identified a few knowledge gaps. We wanted to have the best possible cross-pole data for the tropical cyclone, surface currents. We want to get the radial velocity measurements, this combined, hopefully possible combined wind swell current retrieval. I don't know if that's really possible, but the radar people are smarter than I am. And then, assessing this idea of single variable retrievals versus combined retrieval. The ship track, I want to look at frequency, geometry, viewing geometry, temporal sampling. For the boundary layer study, there is no comparable data set. I believe we have compiled the very first global map of the boundary layer state. I don't think there's anything comparable to it existing. So that's an enormous knowledge gap. We hope we're right. We don't know. And then, there's very little measurement to the mean boundary layer state in a tropical cyclone. It's a very challenging environment to measure. There are new technologies coming in to help with that. And then we really don't know very much about sort of typical turbulence parameters in the tropical cyclone boundary layer. There are very few scattered measurements, and you come up, maybe 20 storms of sampling, you'll get one number, and you don't even know where that number applies. It could be at 100 meters, it could be at 700 meters, you just don't know. And it's one number, but it's the vertical profile that counts. And so validation, we want to cross-compare similar measurements, improve the data flagging. It's good. It would be good to have data flagging, data segmentation, so that you know what to do with the imagery, if it can give you a preliminary sense. Getting 2-dimensional swell spectra far from the coast. In terms of sea ice, there's a big interest in comparing against the upcoming SWAT mission and mixed layer modeling. Tropical cyclones, they have the routine hurricane hunter storm penetrations, and they're developing new PBL probe systems. They have the flying sondes. You drop the sonde and it'll actually keep profiling within the boundary layer for some period of time, maybe hours after being dropped from an aircraft. And then, this IRAP, which is a very high resolution Doppler radar. So this is a different breakout summary, I think, from most of the others, but this is what we focused on. Our key focus was just getting organized to produce a white paper and to set a schedule for everybody to do their homework. And then Justin and I will edit it all together for internal review, and then turn it in to Johnny for the grander scale external review.
Oh, there was a question in the chat.
Oh, okay. I can't read it. Can you read it?
Yes, so there's a question in the chat. Are these ML techniques applied to high resolution LAS-like numerical experiments? In other words, are transfer learning techniques been applied? Can the C-band VV polarization ML techniques be applied to C-band, HH to KU band, and so on?
Can you read that again?
Can the C-band VV machine learning techniques be applied to C-band AH to KU and so on?
Well, we would certainly hope so. I mean, there's a very limited amount of wave mode data in horizontal polarization. I don't think there's anything in cross poles. We would have to rely on one of the other imaging modes. And I think I didn't read it closely enough to pay attention to what modes the IW, the metas are. Do you remember, Justin?
So it's only Mediterranean, so it's only VVVH.
Okay, so I think it is possible, but it hasn't been done. I can't see any reason why it would not be possible. But, you know, the different imaging modes are going to show you something different. You know, cross pole is going to be more sensitive to the, you know, the higher wind regime and the modifications of the backscatter in the high wind regime than it is to the lower wind regime. And it's much less sensitive to changes in direction. But Hans, I think, had an answer.
Domain transformations going from one polarization to another in machine learning techniques appears to be or looks simple, but it's a lot more complicated. And you cannot take it for granted that all the training samples you did in VV just simply apply in HH.
Oh, yeah, I completely agree. We would be starting from scratch yet again. That would be the third start from scratch. And it took us a good 6 years plus to get from the beginning to where we are now. And yeah, I mean, it's not I didn't mean to say it would be an easy job. I just don't think that it's an impossible job. It isn't clear to me what the trade-off would be in terms of going to cross pole, just because if you're trying to extract atmospheric images, for example, the cross pole is less sensitive to the small wind changes in the low wind regime where most of the planet lives. So is there another question on the chat?
It's more of a comment. It was actually the comment I was about to make. So thank you, Christine, for this. Machine learning has much to offer, but it should never become a replacement for physical understanding of the ocean surface processes, microwave scattering, and SAR imaging.
Preaching to the choir. I mean,
Yeah.
I completely agree. I mean, there's no, but I mean, that was the clear thing, is that there was this transformation from process-oriented study to machine learning study. And I think that reflects a certain aspect of the changes in science going on around us and the rise of machine learning. I mean, machine learning has exploded in order to sell you stuff, but it's diffused into science. And it has been a rapid, I think, an exponentially growing aspect in atmospheric science and oceanography. I mean, I go to the atmospheric science seminars frequently, and I'm always seeing this machine learning application and that machine learning application. They're trying to develop climate models that are just machine learning models based on studying ERA5 analyses, and then building a model that will say, okay, you've got this state today, let me look, okay, it's going to look like this 3 days later. And that research is being done. They're trying to develop the subgrid parameterizations based on machine learning. Machine learning is going to be a fact of life. It's up to us to do it properly and to dampen the over-enthusiastic response of people excited with new toys.
Yeah, there's one more comment on the chat. Still, GMF were already ML techniques.
I'm sorry.
I don't know. I don't know what that means, but
The
well,
GMF, the classic GMF guys, they were simple linear regression tools. Now the machine learning you are using, guys, are simply non-linear regression tools. So it doesn't change anything. It's just matter of fact that we are simply using the same techniques as before. Before we were complaining about the number of data to make the GMF say the wind out of the VV to have so little data set. And then suddenly we were using the tripole collocation because we could rely on the ECMWF model output. So the same idea is in between the machine learning. Machine learning has always been existing and will continue. Now we have to switch to artificial intelligence, which is completely a different field. So be careful when you are doing this. Machine learning will always exist. It's not artificial intelligence. And
yeah,
so that we have to comment.
Yeah, I would completely agree with that. I'm completely in agreement with that. Okay, thank you.
question to Johnny. There is coffee outside. Should we break for it? Yes. Okay, we are moving on to the applications wrap up. We should have a presentation by Michaela Corvino, but she has to set up this remotely.
Okay, so good morning all. So we collected some initial recommendations for the application topic, in particular for the subtopic of the maritime surveillance. So we discussed in the plenary and also in the breakout section about the importance, of course, of improving the target detection and characterization, but also to have more effective techniques to improve also the analysis of activity of the vessels. That, of course, it's of critical importance for a wide range of applications such as maritime security, law enforcement, IUU fishing, and so on, and also maritime safety. So one of the topics that we were discussing was the improvement of existing prototype service chain combining SAR and inverse SAR workflow, which allow to improve the refocusing capabilities, but also to analyze the motion parameters, to start to estimate motion parameters. What needs to be done is to analyze this hybrid service chain, in particular in complex real cases relevant to maritime security. In particular, for example, where are complex movement of the target, which can determine changes of the imaging planes, and of course, this require additional effort on the steps of the service chain that are applied to the refocusing algorithm. Then additional needs, there is an additional needs also to improve, to enhance the focusing, but also to better estimate the velocity estimation and its validation that so far has been done through IS data. So also there is an interest to exploit new functionalities, in particular the target 3D characterization, but also to test bistatic and multistatic, when they will be available, SAR configuration, and also to exploit polarimetric and multipolarimetric data. So as said before, the moving target recognition is very important. There are also new products that are provided mainly by new space companies, in particular, for example, the VideoSAR product that could be, of course, of interest to in particular, the tests on, again, on real use cases on maritime, on real scenario. to analyze the slow speed moving targets vessels. Additional optimization is also needed here on the imaging algorithms that are so far analyzed, because this is, of course, still a starting new application. And we are working also on additional applications that are more relevant to land applications. As said during this week, of course, data fusion is of utmost importance for maritime surveillance. We have, of course, we are still combining IS data with information that are derived by IS, but now there is also the opportunity to detect, to have information on emitting radars from vessels by using satellite-based radio frequency from commercial operators. Of course, there are some issues that are relevant, for example, to the data format and the volume of this data that have an impact on the data fusion complexity, and so a dedicated solution should be analyzed in order to have a near real-time application. Another topic, of course, of interest is to improve the forecasting, the route forecasting that is based on IS data. For example, by using deep learning techniques that allows to fit gaps in the data collection. Because, of course, this is interesting to give additional insight on, in particular, on anomalous behaviors. And so, of course, there is the exploitation of deep learning-based approach, not only to improving target detection compared to classical techniques, but also to traditional techniques like SeaSAR, but also to improve the long track reconstruction and forecast, and also to have a more efficient correlation between EO and vessel positioning datasets. Then we discussed also about the topic of microdoppler, which is also an interesting new techniques, emerging techniques to have additional insight about the target in particular, in this case for target recognition, because it allows in some way to give additional information on the structure of the target. But also here, this is an emerging techniques, so we need to start to developing a proper prototype service chain to test the prototype to modeling and to extract micromotion effect on target on real data set on several kind of course of SAR acquisition on this different sensor, but also here is also dedicated effort should be devoted to the validation campaign. During the breakout section, we discussed in particular about the use of deep learning, and there were some recommendations raised by the participant, in particular to have the possibility to access open reference dataset for machine learning, in particular for the IS, with an eye for the historical IS, to have them with an higher flux rate, but also to have the possibility to access open data and models, for example, for the wake detection from the research community. This will be, of course, very beneficial, but we know that there are some constraints that are also relevant to the fact that there are commercial companies working and providing data as service, including this kind of data set. And of course, additional effort should be made, and also recommendation by ESA to set standard for AI-based training data set, in particular for vessel, and for wake detection, but also recommendation will be needed to have standard labeling methods. I think this was my last slide. So I think that in terms of timeline, we could see that we are also aligned with the timeline that was discussed before. So to have a final white paper by the end of December, And I think that it is also important in some way to collect for the white paper that will be relevant to the application, also inputs from external community, in particular community of end users, which work then operationally with this kind of applications. And that's all from my side. I think that I don't know if there are questions or I leave the floor to Kathleen. Thank you.
My slides are somewhere. Okay, thank you very much, Mikhail. So for the slicks and the other topics, and in addition, at some level for the marine surveillance topic, one of the main recommendations is that there be a curated public repository for resources similar to the Ocean Virtual Portal. And this would be a source for viewing and downloading co-located data sets. Think SAR, optical, and derived data sets. And we encourage scientific level traceability for most of those data sets. For example, providing documentation similar to that required for the NASA DAX that include the source for derived data, the algorithms for generating that data, and all of the information, time, location, keywords, type of data, a standardized set of metadata, and DOIs so that data sets of this type can be referenced when they're used for other studies. Also, a similar and perhaps the same portal for shared open source code. In addition, for code for processing in the cloud, because with some of these huge data sets, you're not going to be able to really handle downloading. And in addition, there's a cost for downloading from the cloud. And this could be a portal where the shared open source data, code could be in beta, but it could also be in vetted versions that people could then also reference, perhaps with a DOI, so that you can have full provenance of the code and exemplar output. In addition, of course, we're interested in scene-specific AIS data. I think the plan is to have AIS data for Sentinel C and D. If that is a plan, then we definitely encourage that. It would be nice to establish some data sets from the Sentinel-1 AB archive with this information for selected locations. I think this would probably be something that's coming from the community, not from ESA, of course, but we include it here as something that we think is important in the manner of providing data sets for machine learning or other methods. For mineral oil releases, so slicks, spills versus lookalikes, although we encourage the use of machine learning, We think that machine learning needs to be physics informed. So you need to incorporate the physical information about winds and waves, and also the information about the sensor. So the noise equivalent sigma naught is really important for understanding these radar dark phenomena. And, maybe moving from machine learning that's just differentiating a cat from a dog from a fish to something that includes this kind of physics-based information will help us to understand more about the processes. And of course, we need large data sets of this type for training and testing. And ideally, those would also be available on that portal. One of the big outstanding issues and the areas where a lot of progress could be made in is in characterization of the marine mineral oil properties, in particular thickness, and from SAR. And for that, we really need more field experiments for algorithm development validation, or field experiments at long-term sites with natural seeps, and think this could be part of that super site off of California, Santa Barbara area. And this should be done in combination with multi-SAR sensors. So in this case, we're talking about L band, S band from NISAR, along with C band from Sentinel, and also optical sensors. Then in addition to super sites for mineral oil studies, then think about the possibility of super sites for marine debris, and also, sustained acquisitions over areas with severe oil pollution. And in particular, I was thinking of the Niger Delta as an area where we really would like to be able to document what's going on long-term in that area. So a broader recommendation, speaking as a NISAR person, I think that this group should come forward with a recommendation for SAR coordination with NISAR. We should engage with the NISAR management for supersite or natural laboratory data to support oceanographic and atmospheric science, acquire dual frequency data from NISAR. So this means taking the request to both the ISRO management and the NASA management. Think maybe start out with a small number of locations, because you're probably not going to get a great number, but really think about including NISAR and a request for a small amount of data, sustained data collections in some number of areas where you can do some real multi-frequency studies. So that's my recommendations.
No questions nor comments online? Anyone in the room? Everything is clear.
And thank you, everyone who was there last night, for a very memorable birthday party.
So, future missions. Last but not least.
Okay, there we go. Good morning, everybody. Okay, we're still here. We're still going. Good. We met in 3 dedicated sessions, and we spent a lot of time discussing many, many different things. We sort of cross-cut all of the different themes and ideas that have been discussed in plenary in the last few days. And the primary objective was, first of all, let's decide how we're going to write this white paper that Johnny had dumped on me because Marcus is not here. But Marcus is going to help us and possibly even write the paper. But as far as we're concerned, what we need to do in the white paper is to review new international SAR missions and identify the limitations and the gaps of the ocean SAR applications. And it's kind of an important statement because in the end, the limitations and the gaps are not just about the data. It's about many different things. It's about people. It's about software. It's about how ground segments are changing. And it's about how the actual space segment and the satellites that we're using is changing itself. So in terms of missions, can you hear? Okay. Is that better? Is that better? Better? Yeah, this thing's stupid. Okay. This one. Is that better? There we go. Right. So in terms of the space segment, we have a rich space segment. We have the Sentinels here. I include Simmer as a matrix that will allow us to have a background field into which you can drop the snapshots that are largely delivered from the synthetic aperture radar missions. But you can see that we're evolving. We have biomass, we have SWAP, NISAR, NISAR now, NISAR when it's on orbit. We've looked at sun glitter on various projects like Sarong, which Bertrand Chaperon led, GeoSAR concept we heard about. So we're really rich. I think we've got a lot of things on our table and a lot of things are moving forwards. So we will refine this table in the white paper and we will try to bring it up to date. This was done last in 2019, as you can see in the red line there. We can add a few more things. We have a combination of research missions, operational missions, but also, if you like, new space / commercial missions that are very, very important. And I'll come back to that because it's, how do we coordinate? How do we get the best out of the space assets to do oceanography? Because we're SeaSAR, we're not just SAR everywhere. We are trying to focus on the ocean here. So user community development, surprisingly, what we see is that the SAR data, as we understood 20 years ago, is very, very complex, even too complicated for us to understand. And for many ocean applications in a sustained mode, you look at the SAR image and you think, okay, that's good. What does it mean? How do I interpret that? How do I use that in my work? If you do a case-by-case basis for process studies, it's fantastic. If you want to try to do something systematically, it's very, very difficult. But at the same time, we've invested in Copernicus and we have an operational system. We have C-band and L-band plus SAR-enabled nadir altimeters and imaging interferometers. They're all here or coming. Even though sometimes the primary application is not necessarily the ocean. And they're complemented by the research missions like Harmony. Harmony is there really to try and assist us to understand what we're looking at, which is a bit sort of ironic. And the same for SeaSAR. We want to understand the details. We want to go further. They're almost verification validation sensors for what we have in the operational context. And this was a key aspect that was raised by a few people, Bertrand on one side, but several other people. We need to have missions that are enabling us to understand the SAR, to verify, to validate what we actually see in the data we have today. We also need to make sure we have consistent products. I mean, at the end of the day, users shouldn't really care end users shouldn't really care. They should be agnostic as to where the data comes from. Yes, there are caveats on each sensor. Yes, there are limitations and strengths. But nevertheless, you should be able to pick up a wave spectrum. You should be able to pick up a wind field that is coming from SAR, and it should be fairly agnostic if we're serious. If we're serious. I mean, if we're scientists, we can always spend hours looking at this, and we love it. It's great. We can talk about the beauty of an individual image, but that's really not going to help us. In the end, we need to translate that information to knowledge and package the knowledge in the right way so that users that really don't want to spend a lot of time looking over a SAR image can use the information, the knowledge content. And that's something I'll come back to again and again and again. How do we do that? We have lots of demonstrations of what can be done, and they're beautiful. They really are beautiful. We see some here. We all talk about them throughout the week, but we need to transition. SAR needs to sort of grow up. It needs to go from teenager to mature adult. It needs to stabilize itself. It needs to package things in the right way. It needs to get serious. And it's quite worrying when you think about what we were looking at for the competition of trying to just classify what we see in a SAR image from wave mode. And we can even host a competition because we're not quite sure. That's not really mature, right? I mean, that's not really mature. And that's a serious point. If we're going to be successful, we need to grow up. Now, if you go to the CMEMS catalog, CMEMS being the Copernicus Marine Environmental Monitoring System, where we invest enormously in ocean forecasting, so modeling and in situ and satellite observations, there are some products there that include SAR. So the SAR products are the two-dimensional directional wave spectra, both near real time and non-time critical, sea ice drift, sea ice concentration, icebergs, but not much else. Is that right? Is that what we want? Is that leveraging the investments that have been made in the infrastructure that we have today? I think we can do better than this. But that sums up what I'm saying here, that there's a maturity issue. And we need to actually translate a lot of the things that we're presenting into something that can be sustained, that can be packaged and extract the knowledge. So we wanted to understand wave mode a little bit more. So who is actually using wave mode? Lotvi's gone home. Lotvi is using wave mode at Meteor France. Sure. What about others? So we called the Met Office in the UK and we said, hey, are you using the wave mode? And they said, well, not really. No. It's very complicated data. It's not consistent. It's packaged in a way that's quite difficult for us to use. We're going to have to invest enormously in people to not only build the observation operators to use that data, but then we have to sustain it. So we need other people that are going to look after the quality control and the interpretation and the assimilation system. So that's not quite good. I was a bit shocked, actually, and that's something we have to work on. They like the idea of fireworks. They can replicate fireworks in the model, and they are doing that now. So they will look at the partitions and also the spectral bandwidth of interest within the SAR, and they can use the model to actually generate the same parameters, and they can do like for like. So they're interested, but we need to move this on. 20 years on from the first SAR, this is not a good situation. So there were great opportunities. I mean, if you look at the CMEMS research and development strategy, which is perhaps where Roselle and Sentinel-1 come from. Roselle and Sentinel-1 aren't built for us directly as scientists. They're built for operational systems, of which many of you are part. And many of you feed in and you work on those operational systems. So we have to go to the formal documentation that says, well, what do you really need? And if you look at the 2021 strategy, you can find statements that say there are great opportunities to address the need for better synthetic aperture radar. But it's the opportunities here. We need to consolidate. We need to grow up. Merging of sensors with different spatial resolutions is a promising way forward. Evolution of current status should include more automated use of SAR. Exactly what Justin and people were talking about the other day. How do we classify? How do we bring some rigor? How do we bring some structure into the somewhat chaotic, if you like, images that we see in SAR? Beautifully chaotic, by the way. It's not a negative thing. It's a beautiful thing. So they want to see in particular sea ice observations. We know that we can do very well with sea ice in SAR. They want more on ice type, the thickness, but it's always in synergy with other sensors. And advanced signal processing is key here. We've talked about it, Johnny mentioned it, and it was mentioned several times this morning. Bringing the synergy together means actually getting knowledge, extracting knowledge out of that synergy. Not synergy for synergy's sake, but what is it that we need to deliver to these people whose day job is to deliver forecasts and deliver information to key users? And I think here, our breakout concluded that there is really a need for a common focus, real common focus across the different SAR missions to optimize the manpower. The room's not full here. The online attendance isn't full here. Given the fact that we've got several satellites that are operating right now acquiring data, we need to think about the next generation. We need to think about the bright young things. I love Werner, I love Johnny, I love myself, and I love all of you here, but we're not going to last forever. Where's the next generation? We need to make sure that the synthetic aperture radar community is attractive and not something that's quite scary because it's so complicated. We're not doing a good job there, that's for sure. So one of the things that we concluded is that we recommend a dedicated SAR Ocean product development workshop because that's what's needed. We need to understand how to reconnect with the users, the end users, to the SAR data that we have and try to mature up some of the products that we're putting out here. And it is about people. It's about making sure that we get bums on seats to do jobs, not just the science community, but actually connecting with the end user community. Without a question of doubt, the SAR provides a beautiful instantaneous snapshot. It's the iPhone in space, and it always delivers, well, not always, but quite invariably delivers some fascinating imagery of a highly dynamic process, both in the atmosphere and in the ocean. And again, I refer back to Justin's talk, and I think it was really good to see that people are actually going into the wave mode and trying to make sense of this huge data set. But again, maturing our understanding of information content, the systematic knowledge that's embedded in the SAR image, in the imaging process, the atmospheric process, the oceanographic process that is embedded in the signatures on the surface that we are revealed by the SAR is really difficult. I mean, we showed you some sun glitter, and with the MESA data from NASA, it's really, really challenging. You know, you change the incidence angle just slightly, and we all know this, but when you see it visually and you go, wow, if I change by 10, 15 degrees, I can get a completely different signal. And I need a whole new process, understanding to interpret what I'm looking at. And that is really empowering, but it's also this whole business of teenagers. We need to mature. We need to go beyond the teenagers. We can always have these great discussions, but we need to stabilize somehow our view for the end users to make sure that the products are going out and they will really serve the user needs. We're not able to resolve diurnal signals in SAR. Many of the sensors, if not all, are in the 6 a.m., 6 p.m. orbit. We have no idea how the diurnal signal is modulating the signatures that we see in the SAR imagery of today. And even the constellations that we have, if you include all the new space, we can get a little bit towards that direction, but not everywhere. GeoSAR we heard about from our colleagues in China. Maybe that will help, maybe not. There are challenges with that kind of a system in terms of the dwell time necessary to get your SNR, which means that everything's moved, and perhaps we can't image everything we need. But let's see. And again, I go back to the roughness. What we see is roughness. The radar is responding to the roughness at different frequencies, but it is this ocean atmosphere interaction. It's really undersampled, really undersampled. And that's a big issue. You know, we can think about the snapshots. How do we interpret? How do we use the snapshots? How can models assimilate that kind of information, take the knowledge without actually kicking the model so badly that it becomes a jerky model, perhaps like Sentinel-1's Doppler. So we need better coverage. And actually, if we think about what the SAR can bring, it is a manifestation of the complexity of the ASE interface. We shouldn't be frightened by it. It's potentially a game changer. It always has been. And 20 years on, it still is a potential game changer. We need to find ways of bringing the models that we understand, our empirical models and our physics models, and we need to understand how they bear on the imaging content that we see in the SAR. And we see that in CMEMS, and we see that in COAMPS at the United States Navy. All of these people, they want more data, but they need some stability. So we talked a lot about super sites. I don't particularly like the term super sites or test sites because we've tried that before, but I would propose that we try another way now, which is fiducial reference sites, FRS. Fiducial because we have a different area in the European Space Agency called fiducial reference measurements that is funded and is attractive. Maybe fiducial reference sites is the phrase that will attract the interest of the member states. Then here we're looking at maintenance over long decadal time periods. We're looking at not thousands, but less than 10 of these sites. They're fundamental to understanding the information content and knowledge within the SAR image, interpreted through different ways, interpreted through sun glitter, interpreted through sea surface temperature, interpreted through ocean color, etc. And they're also there to enable and empower simulations. They're a reference data set. So multi-sensor synergy is really important. They must include a broad representative number of locations. Okay, so like I say, 8 to 10 of these sites, light winds to extremes, because that's what we need to do. We need to sample the dynamic range. They must be regional, so 300 kilometers, so that we can actually look at the mesoscale. We need to have these systematically populated and available to people so that they can use the data sets. I talk about this multi-mission reference data, MMRD. They should include not just the satellite data, they should include in-situ data, ocean model, whatever is necessary to try to get to grips with the complexity of what we see manifest in the SAR image, i.e. the processes that drive roughness, which is really amazing, but also really complex. We need to make sure that we have in-situ observations, but we also need to be realistic. If we're not realistic, then we will kill this kind of concept straight away because it'll be too expensive. And we need to understand the complementarities between the different sensors. And that's effort, that's work. That's really beautiful work, actually. If we had time, these days I have to look after other things, but that's what I would love to spend my time on. And we have to be serious. We can't rely on opportunistic methods. They have to be, these things have to be professional. We can't just rely on somebody else doing the job for us. We need to have clear boundaries about the precision, about the uncertainties, and about what we need to do our job. of verifying and validating SAR. And that's no more for the operational missions as it is for the research missions such as Harmony and potentially SeaSAR coming up. It's funny that we have operational SARs, but we've got 2 more SARs here, at least to understand what the hell is going on with the ocean surface in a strange way. It's a big investment, and it demands a bit of commitment if we're going to secure a long-term partnership between different space agencies to make this happen, and also the operators of in-situ observations and networks. But I think maybe that is the way that we can engender and empower the lack of people that are involved in SAR today. So now we should really go back to the future missions. So the mission compendium, if you like, what is it that we're looking at? Well, we've got research missions, we've got operational missions, we've got commercial missions, and we've got proposed early mission development sensors that are coming to bear. Out of all of that, one thing that does emerge is that we need to make sure that if we're really to realize the full potential of Sentinel-1, there really is a clear need for radio velocity to be provided as a core product. And that's lacking today. It's not there. It's coming from my agency. We discussed it with Nuno Miranda, who is the mission manager for Sentinel-1 and Roselle. And I think he's very sympathetic to the situation. But, you know, today we know that we have a jerky steering that doesn't help us here. And this is just an issue. It's something that we have to overcome. There are ways to overcome it, and Dr. Fab and others have demonstrated that. But I think the key recommendation here is let's establish a good product. Now, it might not be the best product in the world, but we have to start. So that's a clear recommendation. Then if you think about Doppler wave scatterometers, we propose SCIM, we have CFO-SAT. What comes next? Where is it? Who's going to build the next CFO-SAT, SCIM? That's a little bit unclear. Yet we can see the beautiful data that comes out of the CFO-SAT today. And imagine that if it was Doppler enabled and you could do the SAR processing, even better. We really need to think about this. It's all very well to have Odyssey and the programmatic framework in which we work, which we live, and that's what it is. But nevertheless, if we don't maintain wave Doppler scatterometers, where is the wave information coming from? And that's really important. And that brings me to the virtual constellation. I mentioned several times, we have quite a few sensors in orbit today, and there's more coming. So we need to push a little bit more to ensure that the coordination of the virtual constellation of SAR sensors is actually moving a little bit in the right direction, not just for land, which is where the primary focus seems to be, but also recognizing, hey, you know, the ocean, 74% of the planet, also needs a bit of coordination as well. We have, in that constellation, the potential for short revisit times. We can task each satellite within regions of whatever and however each satellite itself has its own tasking to optimize for some of the ocean opportunities that could be brought to bear. So coordination of regular repeat coverage of the ocean using an ad hoc constellation is really important. It's really important. There is a CEOS working group to do this, but we're the community that should be pushing and really empowering this for the ocean. That group largely talks about land. Let's make sure we have the ocean on the page. In terms of polarization, several talks earlier on this week, and even in the reports back from the breakouts, we need to ensure polarization diversity. That's really important. We need to keep the HHVB on SeaSAR. Alejandro, where are you? He's up here. We need to do that. We also need to make sure that the quad pole on Sentinel-1NG is maintained. This is important. We know that. Without that, we know on the ocean we are substandard to what we can achieve in terms of interpretation. The SWAT mission is launched. It's a really special mission. It's a beautiful demonstration of technology But at the same time, it's going to be a beautiful demonstration about where we could go. It's going to take a lot of effort, and it will take a lot of effort over several years to really get to grips with the information content, the knowledge embedded in the imagery that comes from that mission. It's not a wide swath; it's a very narrow swath. It should be called the narrow swath in altimeter. But nevertheless, it's going to be really, really useful. We need to make sure we fully understand the Ka band capabilities. Ka band can support measurements that are in tune, in harmony, quite literally, with the ocean. The 6, 7, 8 millimeter waves that can be supported by the ocean in terms of its viscosity and in terms of its dynamics are really resonating with the Ka band. And Ka band is probably our future, to be demonstrated by SWAT. So I encourage everybody to get behind it. And then the European Space Agency, for sure, we get behind this by trying to build follow-on missions on the Sentinel-3 next generation topography to go in that direction. But we also need to go the other direction, P-band and L-band. We have biomass coming. We have SeaSAR coming. And these are opportunities to get us into a regime where we think about it, we have nice paper work, but actually, now we'll have some real data. And I think there will be some really interesting surprises there, and I'm looking forward to those surprises, because that, again, informs us about how we can use the synthetic aperture radar imagery to tell us more about the ocean surface. So together with the P, the L, the X, and the C-band, and even the S-band, we can do much more. And I think that's important. It's also perhaps a bit local to the European Space Agency, but it's true that, Harmony as a mission is going to bring us some fantastic opportunities to learn about all sorts of things. And it's a really exciting mission. And SeaSAR really complements that mission nicely. And both of these missions will bring us considerable advantages, but they will really bring the biggest advantage when they're flown together. Each one on their own is going to bring us something, but when they're flown together, I think there is something there that will be really, really powerful. And that was echoed in the discussions that we had in the theme breakout sessions. It was a strong signal. So, that's something we have to recognize. We also have to recognize that in order to verify and validate some of the missions that we have in orbit today and those in the future, we're lacking a little bit of capability. And perhaps one of the best capabilities we have is to think about using satellites in the context of verification and validation, solely for that. In the optical domain, we have the TRUTHS mission, which is to be launched to maintain a reference for visible radiometry. Maybe we need to think quite hard about what would the perfect satellite be to do the verification and validation. And we had in the European Space Agency the STREAM proposal, which was doing just that. And they were looking at radar and optical glitter to try to get at a way of making sure we understand the detailed content of the imagery. So validation remains a problem. It does remain a problem. We have so many processes embedded in each SAR imagery, superimposed like a wave model, that we really need to work hard to get to grips with how we address these. And I think here's where we start to think about, well, what do we need to do? 20, 30 years ago, we used to be able to promote and propose big international efforts to do these kind of jobs. These days, it's not the fashionable thing to do, but nevertheless, and this is for Bertrand, there is hope. There is hope that we can do something really, really good. And we just have to dream. Sleep is for the dead. We have to dream, we have to push. And what we need is a holistic ocean atmosphere process experiment. We all need that. And this kind of experiment would be in the frame of Harmony, SeaSAR if it's launched, Copernicus, Crystal, SIMA, Roselle, Sentinel-6, the SWAT, the SeaSAR, the ALOS, and other SAR missions, Cosmos SkyMed. What we need is to make sure that in the 2020 2029 to 30 timeframe, we need a major oceanographic experiment, a mooring array. And it needs to be sustained, I would say, for 5 years. It needs to be there looking at the detailed fluxes, notably on the ocean side and on the atmospheric side. So we're talking stress, we're talking CO2 that can couple with this. Why do we need the SAR information? What can we do with this SAR information? The synthetic aperture radar data sets will be part of this, but not the driver. It would never work if we have to have a driver on just validation. It needs to be in the form of an international collaboration, I would say, with 8 to 10 large deep mooring spar buoys in the right place, possibly the Northeast Atlantic. We're open to different suggestions, but the idea must be that we can actually capitalize on all the different data sets that we have to get to grips with what we see in the SAR image. What are those signals embedded in the SAR image? They're complex. It's driven by ocean science, and it's there to enhance and leverage the uptake of the SAR data sets that we have today. It's to get the new young people involved. It's to make it exciting again. I believe we need to do that. In terms of tools and simulations, Python notebooks have been mentioned. Some people don't like Python notebooks, but there's a lot of people in the younger generation that do use Python notebooks, and that's their mainstay. Python today does amazing things. I wish I could program in Python. I've tried, but I'm a bit old now. But at the end of the day, it shouldn't be that we're all writing the same code to open an image, to put it on your desktop, plot it on your screen. Now you can start to do something with it. It should be a space agency's job to do that. We don't necessarily do that in the right way at the moment. And I think this is something that we at the European Space Agency need to think about. And I would push, and I will push very hard to do this. I can tell you that the SIMA mission, the Imaging Microwave Radiometer, everything is in Python notebooks. The ATBDs are written in Python notebooks. Jupyter books, actually, even better. We need APIs that allow us to get to the data. We still struggle to get to the data, but we also need to think very carefully about, do we need to actually have the data? You know, remember those tapes that you used to get from European Space Agency, from EOS and Envisat? And for those that lived in that era, you know, we have a wall-to-wall, ceiling-to-floor, or floor-to-ceiling even, array of tapes that were delivering data every week. But we don't need to do that now. We're going back to the mainframe approach. Take the users to the data, give them a big computer, let them process the data, just bring the results back. And again, we need to be on top of that, because SAR is an area where we need computing power, but at the same time, we need a playground in which we can mature and evolve and play with the next generation of Sentinel satellites and other satellites. And this is happening. If you think about biomass, they have the BioPal, they have the MAP. This is being implemented for those missions. We need to think carefully about how we do it for all the other missions that don't have that capability. What parameters do we need? How do we correlate the parameters with the in situ observations that I was talking about if we were able to get our HOPE experiment? So there's lots and lots of things that we need to think about to empower and bring on board the next generation of people. Otherwise, next time we meet, perhaps we don't need a room this big. We also need advanced processing techniques. Maria Kovala was talking earlier, but also the microdoppler. Really interesting. You know, can we go further? You know, the microdoppler signals are interesting, yeah, but they're even more complicated, but they're really lucrative. If you're a government and you want to see ships and you want to know where the pirates are, where can we go with this really, really highly focused data set? How will Harmony, how will Sentinel-1 and Harmony together really bring us something extra? So there are new techniques emerging, and I think improved target detection for maritime security is an easy win for this community, because that's something that governments sit up and say, okay, I want that. And then the science gets done in parallel. But you need the solid, strong applications to make sure that everybody is on board with the sensors. Today we have a lot. Who knows? If we're not careful, we may not have so many in the future. So just to finish up, what's been done by this community in the last 20 years is quite remarkable. So while I'm quite critical about some of the things you might feel, I also would like to say thank you to everybody, because at the end of the day, there's a large number of both planned, in orbit, and proposed missions with SAR capability, and they're doing a great job. So you should be really happy. You've done a super job in making sure, certainly within the European Space Agency and in the Copernicus framework, we have a lot of capability. We also see that in the industrial world, in the private sector, there are commercial missions that are complementing the sort of backbone, solid, big satellites, if you like, working in a sort of uncoordinated constellation. Now we see a diversification. We see the technologies changing in terms of frequencies, in terms of techniques. We see the cross-track interferometer, the long-track interferometer. We see the wide swath altimeters, etc. There's new polarimetric capability. So the field is rich. It's an exciting area to be a scientist in. It really is. So let's make sure we communicate that to our next generation of scientists. Otherwise, it might not be that in the next 20 years. So we're not going to do too much about the orbits, but we have to recognize that we're largely in 6 a.m., 6 p.m. orbits. And I go back to where I started a little bit about sampling and capabilities. Roselle will give us 50% duty cycle for a SAR. That's quite good. It's really good. We would like to have 100% duty cycle so that we can have imagery everywhere. That will take some time. It's been mentioned before that silos of communities are impeding our progress, and so that's something to bear in mind. But that's how the world works. This is not the worst one. There are others that are. There are other communities that are even worse in terms of silo mentality. But I think SAR is a little bit broad, so you're not too bad here. So I think making space for Europe, making space for everybody is really important. And synthetic aperture radar is coming of age. You're an 18-year-old teenager, maybe 19, nearly 20. Now it's time to consolidate. Now it's time to get to grips with exactly what we need to do to extract and consolidate the beautiful information that we have. So thank you very much.
Not going anywhere, Craig. There's a comment on the chat that you didn't see because you don't have your glasses on. The FRS should also serve for beauty contest, high numerical motor efforts at different scales, from DNS, LES to primitive equations. So there's more use to the reference sites.
Yeah. Yeah, Bertrand, absolutely right. Absolutely right. Everything is embedded in the SAR signatures that are in our data. It's manifest from both sides of the interface, and how we get to grips with large eddy simulations, how we bring to bear the best knowledge that we have and the capability to model this is critical. I think you've said yourself in an email that we will never probably be able to model everything to the level at which we would like. And so empiricism will be really, really important. And I think that's where the FRM comes into play. Establishing a data set that gives us the capability of really having confidence in what we see is really, really important. But also, when you have that kind of data set, then it's a treasure trove of science, it's a treasure trove of anomalies, and it's a treasure trove of stability. So together, all of those things help drive our thinking forward. I don't know if that really helps. You were talking also about primitive equations, but again, the primitive equations need to be met with reality. Reality is much more complicated than the primitive equations can cope with. But I think we share a common view on that.
Yes, thank you, Craig. No, so the idea was to bring around the table also people that never saw any direct evidences of the complexity of the RC interface. So like that, if we want to expand on the use of the SAR, including SeaSAR, including Harmony and next generation, we know that we have to perform or to bridge with this very active community developing a numerical simulation, noting that numerical simulations, they need to have this calibration from the observing system. And that indeed, when we have this comparison, it's on both. It goes both ways, improving the interpretation and algorithm validation from the satellite observation, as well as providing key elements to improve the numerical simulation and some of the diffusivity or whatever terms you put in your parameterization. And yes, I think that this okay, very nice presentation. Thank you, Craig.
Yeah, David.
Could you back up to the slide with the technologies, I think it was? No, well, there. Yeah, just a comment there. I'm increasingly confused. ESA, definitely, the European Commission definitely are spending huge amounts of money on platforms and tools and notebooks and huge data repositories. I know that in the polar science community, for the most part, it's not being used. And from what I've heard this week, it seems it's the same in the ocean community. So there seems to be a disconnect between the people who are promoting all of that and the science communities who seem to want to do things the way they've always done them. And I'm not clear on how to bring those two communities together better.
I think it's true. The reason that our theme group went into the CMEMS repository is just to establish that, well, you know, is this stuff there? It is there. I mean, we have wave mode data that's in near real time and non-time critical in CMEMS. We have a lot of sea ice information from the SAR in CMEMS. So it is being used. When I say that on the ocean, we're a bit subpar, it's because the operational systems today are busy doing the operational systems. Our very framework is to maintain a solid operational data feed, which has key performance indicators that demand you will and you shall put data in the right place at the right time, and you have a criteria of 98% availability. And that's demanding. It takes a lot of effort to do that. And in the consequence of that is that perhaps there is a little bit of a disconnect between the science community. If you're not part of CMEMS, if you're not part of Copernicus directly, it's not always obvious why that kind of an approach takes precedence. And so that's why we recommend a dedicated Ocean SAR product development workshop, reconnecting the R&D back into the operational systems. The operational systems will be there. They are there, and they are evolving, and they shall be there for the foreseeable future. That's the whole point of Copernicus. That's an amazing thing. Now it's a question of, okay, we can do more with the data sets that we've got. And I don't think it's true to say that not everybody is using the data, but the key users for which the satellites are developed and the data is provided are using the data and they're making it available. And that is in Europe, CMEMS. Also, don't underestimate what I would call fifth level applications. So Google Earth Engine, the Ocean Virtual Laboratory, these tools provide data, the same data, in a very different way. There is no connection to statistical measurement of who's doing what. The data is free, open, and available. And there's a vast array of users there that are using that data We just don't know about it, but that's fine. Eventually, we will know about it. The best way to do that is just turn it off and see what happens. Then you start to get the complaints. But for the time being, we're grappling to understand the political process of bringing in user statistics, application statistics in a way that is tangible, makes sense for the political framework that funds this stuff, while at the same time keeping this free and open data policy, free and open coding policy, free and open ATBDs, free and open collaboration. And I think that is the only way we need to go. So we're learning how to do that, and maybe the next SeaSAR will be able to report back a different set of statistics that says, well, actually, we didn't actually understand who was using the data, but there are plenty of people using the data. You cannot ask nasty questions. It's not fair. Yanni.
Thanks, Craig. Yeah, it is it's a good summary here. And there is one thing I don't think you are specifically pointing to, and that is that we sitting in the audience here, plus the people on the online, plus perhaps another extension of that group, we need to continue what we are doing, and we will continue to do what we are doing, taking benefit of what we have seen of possibilities and recommendation here. Then we come to one point. That's the funding situation for continuing doing what we are doing, to extend it based on the recommendation here. And we are walking right through into a can of worms or problems. Because the level of funding which is available for this particular type of development towards eventually a CMAM's uptake is ridiculously small. And that is, it's within ESA, the funding for this is probably the best there is, in fact, in Europe today. I don't know what it is like in US, but it is this sustained funding for this over a duration of 5 years at a level where we are step by step taking on these individual challenges and advance them. We cannot get that funding easily through the European Union, nor can we get in Copernicus. And it is, I'm afraid, something that ESA would again step up and do, maybe in partnership with NASA, I don't know. But without any more sustained funding for doing this at the level where we want to do it, we will, and also in the expectation that there's not going to be a big jump in terms of the in situ observing system from today until tomorrow. We will be hampered, and we will finding ourselves in a situation where we are coming back, let's say in 3 years' time from now, and we haven't advanced ourselves that particularly much. So don't forget, I would ask you, I'm not saying blaming or doing anything, I just want to hear your view on the funding situation at the level where we are seeing this one being taken a bit stronger into account. And you are launching these missions under Copernicus, which you are naming operational missions, in which the Commission don't understand why the hell are these operational missions in the need for more research money. So you see, we have a problem there. And yeah.
Yeah, I thought we'd agreed you weren't going to ask difficult questions, but nevertheless. Great things come from great people. And money comes from vision and tenacity and the ability to bring people with you. Leaders are the way that you empower and bring money to bear on a problem. That's why this thing is called hope, because I hope that there will be such leaders. I would love to do this, but I'm probably a bit old and I have other things and I can't do that. But something like this is 30 million euros. maybe 40 million euros. It's a big thing to ask to do this. But if you don't have big vision and you don't have big dreams and you don't bring conviction, dedication, yeah, you won't get the money. At the same time, you can't expect people to just simply say, here's money, do something. Without the leadership, without the visionaries, without the tenacity, without the dreamers, it won't happen. Even if we put money, it won't happen. We quite often put money and we don't have any takers. So I would urge everybody not to be fixated on money, but more fixated on some of the systemic issues that we face, which is where are we going to be in 20 years with the new people? They need to understand that synthetic aperture radar imagery, synthetic aperture radar altimetry, interferometry is super sexy. It's really, really great. It's interesting because it's getting us into the ocean. Then the money will come. I don't think there's a shortage of money. It's how we actually pitch for the money, and it's how we actually make the case to do great stuff.
Thanks. So you've talked about freeing the data, and I think Ralph really nicely showed how freeing the data has been increasingly really increased the level of knowledge from the scientific community, and this happened also with the tropical cyclone observations, with the amount of additional publications afterwards. You're talking about freeing the ATBDs, but again, freeing the ATBDs still requires quite some time if people want to try implement this. I know it's an ongoing view also on ESA side to try to open the processors, and I don't think it was specifically addressed. Is there a goal to open not only the downstream processors like level 1 to level 2, but maybe to give more open source level 0 to level 1, level 2 processors? Because we know sometimes we are stuck in the level 1 or level 2 with some things that we inherit from higher processings that we don't understand, that we cannot play with. And of course, having the capability to know exactly what's going on in there, not only having ITBDs, which also sometimes we don't really have or are not detailed enough, would really potentially also bring a lot more knowledge.
Yeah, fair question. In Copernicus today, the next generation ground segment is by definition open entirely. It's not something that the European Space Agency is doing on its own. This is Copernicus that is driving this, because the Commission realizes that the open and free policy is empowering. It makes things happen, as we heard the day before yesterday. So yes, we do have the first examples of how we're going to do this in the Copernicus Imaging Microwave Radiometer mission. All of the ATBDs are written in Jupyter books. We're in collaboration with NASA, Michelle Gentleman in Washington, who is spearheading on the NASA side how to do this. We're in contact and we work side by side with Haley Evers-King at EUMETSAT, where they're also doing the same thing. This is not something that's nice to have. It's a question of reproducibility. People need to be able to reproduce the results. And when you come to the level 0, level 1, and level 2, and the higher order product story, fine, you can have the level 0, but I will guarantee I'll put 2,000 euros on the table, dangerously, that you would have no idea what to do with it. It'll be instrument source packets, unsorted, mixed up everywhere, straight from the downlink. And you won't have access to any documentation, because that kind of documentation is not geared to the work that you do. It's geared towards a ground segment engineering approach. They're in the business of making sure you get what you want. When it comes to level 0 to level 1, here we have something that we can do, because much of the magic that is done in many sensors, not just radar, but across the entire spectrum, is done there. That's where we apply the calibration. That's where we actually make adjustments. And you know, each of these instruments is like, they're like humans. We're all the same model, but we've all got different chassis numbers. We've all got slightly different idiosyncrasies. And then there's sort of, you know, the idea of calibration you know, it's not a problem to calibrate your instrument, but it's a sensitive area because some people say, well, you're fiddling it. Well, I mean, think about a temperature sensor. You have a bridge with a set of resistors, you have a bias network, and you put some power on there. Of course you fiddle, you optimize that network, you get the best resistors, you get the most stable power supply, and you have to think about the nonlinearities through the Steinhart-Hart equation. It's the same for a satellite sensor. And that's why we're trying to fly tandem missions, so we can get to grips with that. You can always get the level 1 data in Copernicus. You can you can get the level 1 data in our Earth Explorers. You can get the level 1 data from all the NASA missions. It's complex, it's difficult to use, but that's where the magic does. What I'm surprised about is that we have Sentinel-3 with 80 hertz nadir altimeter data, which has got a very low uptake. This is amazing data set. Yes, you have a different chronogram where there are gaps between and the different bursts, but nevertheless, it's an amazing data set. People might not know about it. So for sure you can get this and do more magic and try to help. And I think the best way to do that magic is opening up the ground processor prototypes, making sure that people can scrutinize the code, making sure that there are useful mechanisms that allow scientists to comment and get their comments into the ground segment architecture. It's one thing to be critical, it's another thing to actually make sure that your useful comments pass through to the people that are actually managing the ground segment, because their job is to make sure not only is it the best, but it runs. And I can tell you that keeping these things running is a huge amount of work. And so if you've got 10,000 comments saying, you have to do this, you have to do this, you know, there needs to be mechanisms to manage that so that we can strip the wood from the trees and really focus in on the important stuff that will bring the next generation. And I believe from the bottom of my heart that opening this up, allowing people to work with the code is the right way to do this.
Yeah, there's a raised hand. Yes.
Thank you. Yeah, I've just raised my hand to try and make sure Craig doesn't keep talking. Craig, first of all, thank you for this really wonderful summary of the discussions we had in breakouts and also through the week. I totally agree with your comment that we need to make sure we get people into this community who have got the grit and the commitment to come up with the vision and take this forward, because that is, as you said, what is needed. People who address, you know, they take on these challenges and stick with it and drive it, and that can be work that can take decades. So let's not, you know, it does take commitment on the long term. But rather than be too pessimistic, I just wanted to, because I'm going to have to leave in a moment, I just wanted to reflect on the fact that we have in this meeting, we have had, you know, some of the pioneers of SAR over the ocean, you know, people like Berna and Ben and others who are not with us, you know, but Will Perry was online at some stage. These are people I have learned what I know about SAR from their papers. I would be interested to know what they make of this, what they heard this week, and reflect back to say how we should proceed, how they see what we have achieved, and what, more importantly, where we should go. I still worry that there's a lot of distraction now brought on by the variety of missions, the vast volumes of data, the complexity of the issues, and the small number of people we have now who actually really understand the ocean process and the SAR imaging. I mean, it needs skills on both of those to be able to make progress with this. And now, in addition to this, the ability to also handle these vast volumes of data. So the complexity of the task is increasing, but we need to make sure that we don't lose the vision and the dreams of what we want to achieve. So I'll be really interested to hear from, perhaps, the earlier generation, the pioneers of what they make of what they heard this week. If they're still in the room.
Werner? Okay. What do you think, Werner?
But you asked Werner that question yesterday.
I did. I'm asking, yeah, I did. Last night for your benefit, Christine, I asked exactly that question in the dinner. I think that's something that we will.
Yeah, I think now using different frequency, Rose L and Sentinel-1 and so using diversity, I think that will be of great benefit in frequency and in polarization. And yeah, so we hope for the future to get good results out of it.
Okay.
Yeah.
Ben?
Saying this to try to stay awake a little bit, but okay, so this is kind of funny, but we used to have a saying in our Alaska satellite facility that was called "Better Living Through Alaska." So I always thought that the way forward was better living through more SAR data, and I actually wrote a paper some years ago on how to get daily SAR acquisitions. And what you can do with 2 satellites or even a geosynchronous one. I mean, it was kind of fun, but it was just a paper study. And so that's what I say, the more the merrier, bring it on, because that's where you get, intriguing things. I think my favorite thing that I still do is look at imagery. I love looking at imagery. I love Dr. Fab's webpage. Years ago, he kindly started including California data, which I thought was great. I just have, if there's rain, all kinds of stuff that's going on. And I just love looking through the stuff. So, so I say, bring it on. I don't necessarily think you need complex systems. I appreciate people that appreciate the quantitative aspect. I've been trying to make sub-mesoscale eddies a sort of a derivable feature quantity, and now it's with machine learning, and it's pretty hard. Even though I like looking at images, I have to sit through and develop these training data sets, and it's really hard. But so I just love exploring the data, and the more the merrier. And I still get so frustrated by the lack of data access to even previous data sets. And I never understood the interest in in commercializing SAR data, because I can't imagine it's a money-making game. But some things are stuck with that. We had extended access to RadarSat-1 data, but we had better access than Canadians did, actually, much of the time. And now there's a great quantity of RadarSat-1 acquisitions that I don't think have ever been made available, that are still stored at CSA someplace. So I'm just thinking the more the merrier. Bring it on, and people will use it and have fun and enjoy it.
Okay, looking at the agenda, we have 30 minutes for discussion, conclusions, wrap-ups. Johnny, would you like to take the lead on that discussion? Or has everything already been said? I guess not, knowing these people. Yes, actually, yeah. If this auditorium would be completely quiet, that would be sad. That's
Yeah, no, I must say that I don't know what more to say. I I think the final summary and recommendation has gone on since we came back in this morning, and closing now with Craig. So, but I leave it up to the audience to sort of eventually have a last saying here, and also including the people online.
let's take it.
When can we get
Sorry, wait for the
slides
microphone,
and
please.
things available? I mean, it's very difficult from all these ubiquitous slides and so on to make notes and so on and try to remember everything. So it would be very helpful to have access.
Yeah, that's clear. And the situation is as this. The entire plenary of the workshop is recorded, so that's available for everyone. Number two, all the presentations shall be uploaded on the SeaSAR webpage, and you can get access to it there. So if some of the presenters do not want to give their slides in PPTX, they may be in PDF, but preferably and hopefully you can see most of that in PPTX.
Yes, and just to remind people that the plenaries have indeed been recorded. So when we meet again in 2043, we actually have quite solid records of what was said.
Okay. Yeah, that can be fun.
I want to ask if the submission list will be also shown on the SeaSAR website. So for example, we submit to different plenary, but we couldn't find what are other contributions. So I think it would be nice if we can find it there.
Yeah, we shall organize the storage inside so it's easy to find it. So it will be stored in plenary, and then sequentially the themes, and then it will be stored in panels and sequentially the themes. So that should be okay. Yeah, and then comment in the chat from Sabrina. So you will all receive an email next week with more details on this login and pickup of the presentations on the SeaSAR website.
I just have one comment, or to go back to the challenge that I posed to everybody. That was really, you know, a way to get people excited about labeling the data and interpreting the information. But beyond that, and if people want to contribute to this after the meeting, I'd certainly be open. I think there's some real nice education here almost, just to look through the imagery, make sure that you, or at least you're consistent with other folks. And that was really the purpose behind it, is to basically some way for us, meaning myself, Doug Vandemark and Ralph Foster, and even the Ifremer crew that have been looking at a lot of these imagery for years, to validate that we're not too off track, right? To use everyone else here to give that. So I just offer that, and maybe I'll follow up next week with an email to see if you do want to contribute. And the idea would be to, label a relatively small sample, 100 images or so, and see if there's some consensus amongst us as a community. Because I heard that this echoed in several of the recommendations, that having some context of what is in the imagery would be great. And even when you develop these machine learning models, sometimes there's no validation source. The only validation source is maybe within the expertise of the folks in this room. And we also can't we can't ask the model to do something that we cannot. In other words, if we are divided on what is in the imagery, we can expect the model will do that anyway. So this is one way to at least establish some error bounds or something of the model. In other words, imagery that we're very certain on and we all agree on, we expect the model would do the same. So that's really the purpose behind that challenge. So just wanted to mention that.
Yeah. Oh, sorry. It's a good comment and reminder, Justin. So that's we shall absolutely build on that in the future approaches for sure. So just again for the late arrivals this morning, and those of you that are staying in the Polar Rig, Marianne, when you're checking out tomorrow, you are not paying. That was a wake up. That was a wake up. Yes, you are not paying because the Nansen Center has paid everyone's costs for staying in the Polar Rig. And that means that you will next week receive an email with an invoice where you are going to pay to us. So we do pay. Yes, you do pay. And of course, the cost that you think is the Polar Rig cost will, of course, since you're paying to the Nansen Center, we have a different price. No, so that should be okay. Any last minute word? No, I think the take home message is quite clear then. We have a job to do, and we see each other in 3 years from now. And we invite suggestions for where we shall host the SeaSAR 2026. So the first one out may be, of course, the one and the best chance of being the one that can succeed in hosting the next one. So, and also I think at the workshop that Craig has already announced for sometimes in May 2024 or whenever, where there will be a focus on SAR products, and is quite a valuable one that will be a good jumping board for us towards the SeaSAR 2026. So with that, I think I will just close by thanking Sabrina and Kat again, and then thanking the UNIS local hosts for what you have done with us. This is a very nice venue for us, and accommodating us all in this big room, and as well giving us the chance to have the panel meeting places was also very nice. And then the easy access to the lunch, the cantina, and coffee, and so has been just making us very efficient. So super nice to Eero and his team. So we give them a big applause.
Thanks a lot. Actually, on that note, Anna and Petter, who've been helping us throughout the week, I think Anna has some crucial information on a very important thing.
Yes, thank you. It's an important message from the UNIS Cantina. So there will be lunch. This will be baguettes and wraps, and you will find them in the glass fridge on the counter in the cantina, and everything is in there is for SeaSAR, so don't be shy. But please just note that the wraps are vegan and or vegetarian, and they should be labeled as such, and the baguettes are non-vegan or non-vegetarian. So good to know.
So if it's inside bread, it's a dead animal. It's okay, good. All right, and enjoy lunch. I will have to leave rather soon after being eaten because I got the message from my wife that my leave of absence from family duties will end 13:30 sharp. But no, I guess that's it. Thank you everyone for being here. Welcome again, and good luck with those white papers.